my ln, so I'm just going to do the x's. So by chain rule, that's a negative. The inside stays the same. Subtract 1 from the exponent. And now I uncover that, but that's a product rule. So it's a first times the derivative of the second plus the second times the derivative of the first. And then the first term is just going to clean up to a 1. And there it is all cleaned up. So now can I make an argument that this is always less than 0?
Yeah.
Okay. What can you tell me about the bottom?
Always positive.
The bottom's always positive. What can you tell me about 1 plus ln of x?
Always positive.
Yeah, well, see, we're only worrying from 2 on, and what you're really doing is taking this picture and doing what to it?
Cropping it.
No. 1 plus.
You're moving it over up 1.
There we go. We're moving it up 1, which made it even more positive, right, for the parts that we're looking at. So here's where we cropped it off, but this plus 1 moves it up. So this is positive, this is always positive, and that's going to make it negative. So we can make the argument that that thing is less than 0, and therefore it is decreasing. So this was a lot of work, because we haven't even worked the problem yet. All we've done so far is assure ourselves that the integral test is legitimate. Now we actually have to do the test. So we have to integrate from 2 to infinity, 1 over x ln x dx. Suggestions? And don't say calculator.
Alright, if you pull out the natural log up, then don't you have like the derivative of natural log x is just 1 over x, so just like separate them.
1 over ln x.
You just have 1 over x times natural log of x to negative 1 power.
Derivative of
Natural log of x to negative 1.
So you're asking to
Yeah,
let
so
u
to the n
equal ln of x.
Yeah.
Then du equals
1 over x.
1 over x dx. And if I needed to integrate then a u to the negative 1 du,
U to the negative 2 divided by negative 2. U to the 0.
It's u. The natural log of.
So it's 1.
Just
U to 0 is 1.
it's just the natural log.
Okay.
The natural log.
all your little careers, I've tried to get you to memorize this rule correctly. The little rule says the integral of u to the n du equals u to the n plus 1 over n plus 1 plus c, and then there's a comma,
Not equal to.
and not equal negative 1. Yes. So what happens is, this is not a power rule, it's a little natural log.
It's just confusing. See how the
I know, but I know it was so tempting to just take that and divide by negative 1 plus 1, and then you go, uh-oh. So when you go, uh-oh, I hope you'll go back and say to yourself, that's the place where I need a natural log. So it's a little funny looking. This is really the ln of the absolute value of u, which is really the ln of the absolute value of the ln of x, now evaluated from 2 to infinity. So I've got the ln of infinity, if you pardon my use of that notation rather than the limit notation. But what do you know about the natural log of 2? It's some number. And when I take the natural log of that number, it's some other number. So this piece back here is some nice little finite amount. But this piece is some big old fat infinite amount. It diverges. And the integral test says that if the integral diverges, so does the series. So finally, our answer is that infinite series diverges. And you should be saying, oh my gosh, I hope there's a better way.
And there is.
Well,
No? Well, I was hoping
not
you-
on this particular one, there isn't. Yeah.
How did that work with the integration?
Yes, this is really the integral of du over u.
Yeah. Yeah.
And that's the ln of u.
Gotcha.
And then I replace u back with what we let u equal. Yeah, like this, it's hard to recognize. Like this, I see that natural log immediately.
I thought we did question.
You don't?